Question number 11. A hockey player skates completely around the two circles shown below. Each circle has a diameter of 14 meters. What is the approximate total distance skated by the skater? Use 3.14 for pi. Round your answer to the nearest meter. All right, let's read that question again and try to figure out what we are actually being asked to find. It says a hockey player skates completely around the two circles shown below. So if I'm picturing this ice skater, I actually used to watch hockey frequently. My husband used to play hockey. All right, let's just say he's skating and he's warming up before the hockey game, and he starts right here. If he skated all the way around this circle, what would we be finding? Would we be finding area, or would we be finding the circumference? Took me longer to write it than hopefully it took you to answer it. The correct answer is circumference is the distance around a circle, so we are dealing with circumference. Okay, so we are being asked to find the circumference of these two circles. Both of the circles have the exact same diameter. So here is one way to approach this problem. The first thing I could do is to retrieve the formula either from my notes or from my brain. Circumference is pi times my diameter. I now know that my diameter is 14 meters. So my diameter is 14, and it does tell me to use 3.14 for pi. So pi, I'm going to be using 3.14. All I need to do to find the circumference of the top circle is to plug those numbers in to the formula and get my answer. So 3.14 times 14 is 43.96. If I were to now stop and be a silly sausage and not look at the question and round my answer to the nearest meter, I might be tempted to select 44 as the correct answer. But I want you to think about what we just found. We found the distance that skater skated around one of the circles. He is now going to skate around the other circle. And so we are going to have two of these. We are going to have two of the exact same circumferences of those circles. So if I then do 43.96 times 2, because there are two of them, I'm going to get 87.92. And when I am rounding to the nearest meter, that means the nearest whole number. In this particular number, the 7 is the nearest whole number. So I'm going to use my 9 to help me round. 9 does round up, so the 7 becomes an 8. So my correct answer is 88 meters. Question number 12. A Frisbee has a diameter of 15 inches. What measure is closest to the area of a Frisbee? All right, now maybe you don't know that a Frisbee is a circle and you're thinking that we're assuming, but because they use this word here, diameter, we know as soon as we hear the word diameter that we're dealing with a circle. So we certainly know that this is a circle shape for this Frisbee. Okay, I've certainly seen some weird looking Frisbees. All right, it then tells us that it has a diameter of 15 inches. So I need to remember what a diameter is. Remember, the diameter goes from one edge of the circle through the center point of the circle to the other edge of the circle. So this would be my diameter. It's telling me that it is 15 inches. It also wants me to find the area. And so the formula for the area of a circle is pi times my radius times my radius. Now, again, this is similar to another test question. It does not give me a radius. It gives me a diameter. I now need to figure out what the radius would be. Remember, your radius is half of a diameter. It goes from the center point of the circle to one edge. So it is half of 15. And to find half of 15, we're going to do 15 divided by 2. You could use your calculator for that. You could do long division. In this case, my radius is going to be 7.5. Okay, so I have now found out that my radius is 7.5 inches. I'm then asked to find the area. It does not tell me anything about pi. It doesn't say use 3.14. I can tell I'm not leaving my answers in terms of pi because I don't see the symbol for pi in any of my answers. In this case, I would be recommending that on your calculator, you are looking for that symbol for pi to use instead of using 3.14. Okay, we'll give you a little bit of a different answer. When we use 3.14 for pi, instead of the actual number for pi, which is infinite, it's 3.141592636. It keeps going forever and ever and ever. When we use this representation for pi instead of 3.14, our answer is going to be slightly different because we are multiplying by all of these additional digits. So when they do not specify what to use for pi, you should use the symbol on your calculator. All right, that was a lot of explanation. I'm going to now go ahead and plug in my information. So into my formula, I know that my area is going to be pi times 7.5 times 7.5. Okay, so I'm actually going to clear all of this. And I'm going to go to Desmos because I know that's the calculator you are most familiar with. So I'm going to make sure that when I'm working on that test, that I've got my Desmos calculator pulled up. And I'm going to show you the key sequence or what you punch in order to get the area. Okay, so I'm going to just write that information back here. It's area equals pi times radius times radius. And so we're going to use the pi symbol times 7.5 times 7.5. All right, so how do I put that into this calculator? I want you to notice over here on the left-hand side of Desmos that there is a little symbol for pi. That is what we're going to use instead of typing in 3.14 because it's going to give us a slightly different answer. So the first key I'm going to hit is this pi key. All right, so I'm going to do, trying to unannotate, I'm going to do pi, and you should see it pop up over here on the left-hand side of my screen. All right, so now you see that symbol for pi, and over here you can see all those decimal digits that it's got. All right, so I'm going to do pi, then the times sign, 7.5. And if I wanted to right now, I could square it by using this a squared key, or I could simply just type in times 7.5 again. And remember, Desmos automatically gives you your answer. You don't have to do anything to get that answer. And so what I see is 176.7145868. All right, I'm going to keep that on the screen, and I'm going to jump back to my practice test question. I'm going to present it. And I'm going to see where we are. All right, so my answer is 176.71. It says, which measure is closest to it? Well, the only one that's close is this 176.6. My guess is that this answer here was found using 3.14 instead of the actual pi key. But either way, they're extremely close to each other. 176.7 and 176.6 are very close. The answer choice C. Moving on to question number 13. This question asks me to solve for X. This idea is building off of your knowledge of angle relationships and different types of angles. The most important thing that you identify in this picture is this orange square in the corner. And remembering what that is telling you is that you have a right angle, and that you need to remember that a right angle is 90 degrees. Okay, so remembering that we have 90 degrees to work with here, I am going to tell you that from here to here, out of those 90 degrees, we've used up 62 of them. Your job is to figure out how many degrees are left for angle X. So what I'm saying is 62 degrees plus something, which we're calling x, gives me that 90-degree angle. The easiest way to figure that out is to subtract. I'm going to do 90, minus 62. 10 minus 2 is 8. 8 minus 6 is 2. So that means that x is 28 degrees, B. By the way, bonus points for remembering that these are called complementary angles. Complementary angles are two angles that when you add them together give you 90 degrees. Question number 14. All right, this is a multi-answer question. Question says lines A, B, and I'm going to highlight those for you in a minute. Lines A, B, and C, D intersect at point E. Determine if each statement in the table below is true or false. Drag and drop either true or false into the box next to each statement. All right, guys, before I do anything else, I want to talk to you about the type of question you're getting. You're going to drag and drop true or false into the boxes. On your test question, on the actual test, you'll see an oval with the word true in it and an oval with the word false in it. You're going to drag those into these boxes wherever they belong. And you can use each of these more than once. If you think all three answers are true, you're going to click and drag true 3 times into the box. You don't use it once and then it disappears. You get as many times to answer as you want. Okay, having said that, I'm now going to highlight your line segments, starting with line A, line AB. That is right here in red. And line CD is right here in pink. And it tells us that those two lines intersect or touch at point E, which you can see is right there. And what they're going to do is they're going to ask us a series of questions based on those two lines that are intersecting, okay? Now, remember, I'm just giving you some sample types of questions. Your job is to really thoroughly be able to use the slideshow to help remind you of all the different types of angles that are formed. On the practice test, what we're looking at is the first question asking us if angle CEA, which is this angle right here, and angle BEF, which would be this angle right here. They're asking us if those are vertical angles. So I guess the best way for me to answer that question is to remind you of what vertical angles are. So I'm going to clear these drawings. I'm going to minimize the test question. And we're going to go back to the slideshow. What I'm doing here is trying to model good test-taking behavior so that you know what I would be doing if I were you and I were taking this test. I'd be going back to either It's Learning where the slides are, or I could go to the slideshow and look for the slide that talks about vertical angles. You can see here that vertical angles are angles that, and then it tells you in the corner box that they are angles that share a common vertex, right? They share a common vertex, that they are opposite angles, and that they are equal to each other. Their degree measurements are equal. So let's look at this picture and notice that angle 3 and angle 1 are what we're calling vertical angles. They share this common vertex, and they are directly opposite each other. They're also going to have the same degree measurement because of that. So now I'm going to take that information and I'm going to try and apply it to the test question. So I'm going to minimize the slideshow and go back to the test question and take a look at those two angles again. So remembering we were talking about angle CEA, which is this angle here, and angle BEF, which is this angle here. And hopefully you can tell that these two angles are not opposites. They are not opposite each other. They do share a common vertex. All right, if I were to notate that, I'd put the common vertex right here. but angle CEA is not opposite angle BEF. It would be opposite angle DEB. All right, those two angles would be vertical, but CEA and BEF are not opposite. They are not vertical, so this answer is false. All right, let's clear all that drawing and go on to the next statement. The next statement says that angle CEA, so I'm again going to highlight it for you, CEA, so this angle right here, and AED. AED would be here in pink, AED. And they're asking if they are supplementary angles. So supplementary angles, if you don't remember, you are going to find that information on your slideshow. So I'm going to go ahead and jump over to the slideshow. And see if I can find information about supplementary angles. Supplementary angles are two angles whose sum is 180 degrees, like angle 1 and angle 2. And they're pretty easy to spot because they form a straight line. That's what supplementary angles are. Okay, so what I'm looking for are on the test question, practice test question, do I have two angles that make a line? Let's go check. And if I look at, I'm going to annotate it again and draw it, angle CEA and angle AED. And what you can notice is that this right here is a straight line. And so, yes, they do create a straight line together, and therefore, yes, they are supplementary angles. So this answer is true. Let's look at the third statement. The third statement says an angle complementary to angle DEB measures 135 degrees. An angle that is complementary to angle DEB would give me 135 degrees. This is your understanding of what complementary angles are. Complementary angles are two angles that add together to give you 90 degrees, not 180. So it could not possibly be 135 degrees. I could not take the 45-degree angle, which is angle DEB, and add something that is over 100 degrees to it to give me 90. All right. If it had said an angle supplementary, if it had said an angle supplementary to angle DEB measures 135, I might have a better chance at having a correct answer. What I would then do is take 45 and add it to 135 and see, do I get 180 degrees? Let's just take a second to do that. 5 and 5 is 10, 4 and 3 is 7, plus 1 is 8. So I would have gotten 180 degrees. So what that's telling me is that I would have had supplementary angles. But I'm not being asked, do I have supplementary angles? I'm asking, do I have complementary angles? That answer is no, I do not. So this answer over here is false. Oops, I spelled that wrong. You get the idea. Okay, we're going to do one more, and then I'm going to pause the video and go on to the next set of questions. The next question is question 15. All right, it says a diagram is shown below. Which equation can be solved to find the measure in degrees of angle DBC? Okay, angle DBC that I'm highlighting in red. Notice that angle DBC is called X. So what they're saying is, how do I find out how many degrees X is? And in order for me to have any clue of how to do that, I have to understand angle relationships. What I see in front of me are two angles whose sum is 180 degrees. If I take this pink angle, which is called 2x plus 20, and I add it to the red angle, which is called x, I am going to get a straight line, which is 180 degrees. And those are called supplementary angles. So what I could do is I could say, I know that 2x plus 20 plus this degree of measurement x, whatever that angle is going to give me a straight line, which is 180 degrees. And I'm going to look and see if that answer appears. Unfortunately, I don't see anything that says 2x plus 20 plus x. So I know it can't be this top answer or this bottom answer because they're missing the plus x. I also know that this correct answer doesn't appear down here. So what happened? Well, they must have simplified. Right? So I'm going to look for my things that are alike. I see 2 x's here, and I see one more x here. And if I add 2 x's plus one more x together, I get 3 x's all together. So 3x plus 20 is then going to give me 180. And now I'm going to check and see if this equation appears. Luckily, it does. It's right here. If it didn't, I would go ahead and continue solving that equation until I bumped into another equation that matched it. The correct answer for this practice test is 3x plus 20 equals 180. Go ahead and find the next and last set of videos.